Hello class, this is a video tutorial on angle relationships. In particular, we will be looking at parallel line notation and the relationships in the angles between them. We have corresponding angles, alternate angles, and co-interior angles. Okay, so here we have parallel lines. It's notated as any two lines with two little arrows like that. And parallel lines are two or more lines that never intersect. So if we extend AB in either direction or an CD in either direction, if we keep going in a straight line, these lines will never meet. And because of this, we can use the notation AB, so this line AB, and two vertical lines like that means is parallel to CD. So this statement here reads as AB is parallel to CD. Here's another example here. I wrote it as PS and QR. So PS is parallel to QR. Now, when we have a line that passes through parallel lines, so here we have WX is parallel to YZ, and we have an AB that goes through both lines. Okay, that is called a transversal line. Or in just short, we just call it a transverse. So AB is the transverse. And as a result of AB passing through these two parallel lines, 8 angles are created. And I've numbered them 1, 2, 3, 4, 5, 6, 7, and 8. And each of these have some special relation to each of them, which we will go through right about now. The first relationship we're going to look into is called corresponding angles. And corresponding angles are equal to each other. The shape I'd like for you to remember for it is F. So it could be a forward F like this, and it's the two angles underneath the arms of the F. So these two angles in the parallel lines will be corresponding, as will these ones. It could also be backwards. It could also be upside down, like this one. You see the letter F. And it's those two angles. And finally, it's upside down and backwards. It's just those two underneath the arms of the F. So in the case of this parallel line, it's these two angles here are corresponding angles. And in case you can't see it, there it is there. There's our F. And there's the arms of the F. Now with that in mind, if we have parallel lines such as this, we can figure out the value of W here because they are corresponding. You see the letter F? So if that is 60, W will also be 60. W degrees is equal to 60 degrees. And whenever it comes to finding the relationship or proving that these two are equal, you must add that these are corresponding angles. You have to include this reasoning each and every single time. So here's another example. So if that angle there is 85, the X is corresponding to 85, so therefore we can say X is equal to 85 degrees. And like once again, there must be a reason next to it. Corresponding angles, because corresponding angles are equal to one another. And finally, one last example. If that angle there is 77, Y is corresponding to it. As we can see, there's that F shape there that's going backwards. As a result, we can say Y degrees is equal to 77 degrees. And for this one, I'll show you the shorthand of it. It's CORR for corresponding angles. So core angles. So that is corresponding angles. The second relationship, angle relationships in parallel lines, oops, let me rip this off, are called alternate angles. And once again, alternate angles are equal. The letter I'd like for you to remember for this is a Z. It might look like this, a regular Z, and it's those two angles, it's the two acute angles in the Z. It might also be backwards like this. You might also be slightly elongated. So here's a backwards Z, but can you see how this Z is actually similar to this one? It's just that it's been stretched out a little bit, as is this Z is similar to that Z. It's just slightly elongated. So which means whatever this angle is, this angle is also equal. So for example, if this angle here was, say, 50 degrees, and we'll label this one A degrees, we can say that A degrees is equal to also 50 degrees. And we also, once again, have to include the reasoning. This is alternate angles. As the same with this one, here's our reverse Z here. So if this angle were, say, 110 degrees, and we'll label this one B degrees, we can figure out what B is, the value of B. The value of B is also 110 degrees. This one is also because they are alternate angles. Two more examples. Here we have a, can you sort of see the Z or the Z? If we turn it slightly this way, we have the Z going like that. So if that's 100 degrees, X is also, must also be 100 degrees. And I'll show you the short form of this. Instead of writing the full, we can just write alternate angles. And finally, here we have, this time's going upwards, but if you take a look, the letter Z is still in there. Just need to turn it slightly this way, and hopefully you can see the Z is going like that. So as a result, once again, we can calculate the value of Y. Y is also 120 degrees because those two angles are alternate angles. And the last angle relationship in parallel lines are called co-interior angles. And co-interior angles are actually not equal, but they are supplementary. And the letter that's associated with it is the letter C. So it looks kind of like this. You might be leaning forward like this. And notice how this one has a single line and that has a double line. That means that these two angles are not equal. It's just that whatever this is, this angle must add up to 180 degrees. So here are the 4 examples that it might look like. But obviously it could be rotated to face up, down, or diagonally. So for example, here we have 2 angles. So whatever this might be, let's label it angle X. Whatever angle this might be, let's label it angle Y. Whatever the 2 angles are, X plus Y must equal to 180. Should put a little degrees there. So if we have here, there's our letter C going backwards. We know that X degrees plus 120 degrees is equal to 180. We must include that this is actually co-interior angles. and we can solve for x. So x will be equal to 180 minus 120. X is actually 60 degrees. And the same can happen for here. Once again, there's our letter C. This time it's facing downwards, but it's still co-interior angles regardless. So we can say A degrees plus 87 degrees is equal to 180 degrees. And once again, the reason is co-interior angles. Let's solve for A. A will be 180 minus 87. This will give me, we need a 3 to get to 90, 93 degrees. Yes. And one last time, there is our letter C again, this time diagonally facing that way. Can you see it? And this one, once again, we can say that B degrees plus 65, make that a little bit more obvious, 65 degrees is equal to 180 degrees. And the shorthand form for co-interior is actually co-interior angles. And we can solve for that letter B again. B degrees is equal to 180 minus 65. This will give me 5. That gets me to 70, 80, 180 degrees. So B is actually 115 degrees. These conclude all the angle relationships on parallel lines, although it's not limited to these three, because you will find that the vertically opposite and complementary angles may also pop up in here as well. Best of luck.